Similarly, for breathing rate, with the results for Wingate, it's shown that the rest has a low breathing rate because there's no demand in oxygen. And pre-test, even after a little warm-up, it does go up. That can also be due to anticipatory rise, which is caused by the release of adrenaline, but I'll talk further about that further on. And then post-test, the breathing rate escalates greatly because of the increased demand during the test, and similarly, post-test, there's a higher demand in oxygen in order to replace the lactic acid and other waste products that may have built up due to the exercise. Most sports which are performed for a long amount of time require oxygen to make energy, which can be generated due to aerobic respiration. Exercise in which aerobic respiration are used are marathon running, cross-country running, and swimming long distances. Continuous training is an aerobic training method. Respiration that occurs with no oxygen present, also known as anaerobic, converts from glucose, which is an energy source, to energy, and then lactic acid builds up. Now on to cardiac dynamics. The cardiac system responds to a warm-up. The way the cardiac system responds to a warm-up is that the heart begins to contract faster, which is a systole action, in order to start the blood pumping more efficiently and allow the oxygen flow to start around the body. Similarly, there will be an increase in the heart rate due to the anticipatory rise, which causes a release in adrenaline, which does have the effect of an increased heart rate reaction, because due to the fight or flight reaction which is caused, the heart will begin to pump more blood around the body to increase oxygen disposal to the muscles. In cardiac dynamics, there's an equation which links cardiac output to heart rate and stroke volume. This is cardiac output equals heart rate and stroke volume. Each of these features are linked in some way, and so if one factor is affected, the overall cardiac output is affected. Cardiac output is the product which is made due to the heart rate and stroke volume. The average values for cardiac output from the heart is around 4 to 8 litres per minute. Heart rate is one of the factors which contributes to cardiac output. It's also known as pulse, which is what you feel when you press against an artery, which can be found in your neck if you feel now, or in your wrist. It is the heart beating. The number of times a person's heartbeat per minute is the heart rate. This can be affected by exercise, as your body is in a higher demand for oxygen, which forces the heart to beat more per minute in order to dispose this. The normal heart rate varies in each person, but a normal range for adults is around 60 to 100 beats per minute. Finally, stroke volume is the amount and volume of blood in which is pumped from the left ventricle, which is the average beat per minute, and therefore the stroke volume and our heart rate are linked, because the stroke volume, which is the amount of blood, has to be rejected and moved due to the pulse. Sorry, I meant ejected. With the experiments we participated in, heart rate was one of the factors which were measured. For the multi-stage fitness, for post and resting level before the test, it's shown that the average heart rate recorded was around 87 beats per minute. This is at resting level. This at resting level is a normal amount because the body isn't demanding a large supply of oxygen, which will be disposed by a faster beat from the heart in order to pump a higher rate of blood around the body carrying oxygen. This is also known as oxyhemoglobin, when the oxygen is bound to the hemoglobin which is in the blood. The fact that resting and post tested the same value might suggest that there is no effect from pre-exercise anxiety / heart rate build up, because there's which are commonly present. However, the results might indicate that the anxiety levels or heart rate is already high. Already, because when being measured for a resting level, this might not reflect a realistic heart rate due to the slight anxiety or apprehension in which the participants might feel, and which may raise the heart rate. However, clearly on the graph there's a rise in heart rate for the person as the exercise begins. Heart rate has an increase. This is because the heart will need to convert its rate from a slow one at resting to having a demand from the body for oxygen, so the heart suddenly will need to increase its rate to fast and rapid in order to pump the blood carrying the oxygen for it to diffuse into the muscles which are needed for oxygen. The diffusion will happen as there is a higher concentration to lower concentration in the muscles from the tissues and vessels. Seen in the graph, this is clear for each stage of exercise that it does have an increase on heart rate, and this can be explained by the demand for oxygen to the muscles as they convert into anaerobic respiration. There will be the need to replace the loss of oxygen. Post-test is when it's also high because the heart needs to pump the blood similarly as fast to remove the lactic acid and waste products which have built up due to anaerobic respiration conversion. Due to the increase in heart rate due to exercise, this will change the overall cardiac output. The tidal volume will have changed also to match the increased need for oxygen, which therefore will cause the overall increase in cardiac output. Similar results were provided from the Wingate test, which showed that there was an increase in heart rate during and after exercise, which provides evidence for the fact that exercise causes an increased heart rate. During exercise, the cardiac output increases more than the total resistance decreases, so the mean arterial pressure usually increases by a small amount. The cardiac output increase is due to a large increase in the heart rate and a small increase in the stroke volume. There are 3 different graphs on this page as seen, which show the effect of cardiac output, that show heart rate and stroke volume on the power exerted. Each have a steady increase after exercise has increased. In the body, the arteries will carry the blood away from the heart. As the blood travels through the arteries, it is pressed against the walls of the arteries. Blood pressure measures how hard the blood is pushing against the walls of the arteries when blood is being pumped through the body. The first is the systolic pressure, which is the top number, which shows the amount of pressure in your arteries due to the contraction of your heart muscle, and in contrast, the diastolic pressure is the bottom number, which refers to your blood pressure when your heart muscle is between beats and relaxed, not contract like systolic. Systolic blood pressure will increase during exercise because there is a higher demand of oxygen to be delivered to the muscles, so therefore the blood needs to be pumped faster, which means more contraction of the heart to eject the blood over relaxation of the muscles. So therefore during exercise there is more blood being pumped, so the blood pressure increases because there will be a harder push of blood against the walls of the arteries as it is rapidly pumped through. In order to work out the total blood pressure, you would times the cardiac output by the resistance flow to flow. The equation is known as BP, which stands for blood pressure, equals Q, which stands for cardiac output, and RF, which is resistance to flow. There are resistant factors of blood pressure in the body which include viscosity, which is the vessel length, and the vessel diameter. With a thinner, smaller vessel diameter, there is a smaller surface area for movement, and this causes more of a push of blood on the walls, on the vessels, because there is less room for the blood. And especially during exercise, during systolic pressure, there will be a pulse movement of the blood which will cause a higher blood pressure, and this is added to when the vessel diameter is smaller. The pressure in arteries is increasingly high, and this is an example of a vessel where there is a small diameter, and one reason the pressure within is so high is because of the small centre lumen. Viscosity describes the internal friction of a moving fluid, which in the body is the blood. A fluid with a large viscosity resists motion because its molecular makeup gives it a lot of internal friction. After exercise, viscosity is seen to increase significantly, and subsequently return to baseline levels within 1 hour after exercise. The whole blood viscosity increases by a similar degree after heavy or light exercise. There's no difference. With vessel length and blood pressure changes, the length of a vessel is directly proportional to its resistance. The longer the vessel, which is the structure which carries the blood, the greater the resistance and the lower the flow. This is because there is a longer area. As with blood volume, this makes sense as it increases the surface area of the vessel, and it will stop the blood flow. You usually get your highest blood pressure at systolic level, which is usually around 122 millimeters per mercury, which is the pressure of when your heart beats, which is the contraction, which is a systolic pressure. And for diastolic, when during exercise there is less of a relaxation, that's usually over 80 millimeters per mercury, which is the pressure when your heart relaxes. For the resting heart rate, the target is between 60 and 100 beats per minute. There is contrast in the blood pressure of vessels of different sizes because they all have different lumen sizes, which affect the blood pressure because there is a different force being exerted onto the walls when they're at different distances. For example, blood pressure in the capillaries is around 20 to 30 millimeters per mercury, being small, and the vessels small in diameter also, whereas the pressure in the large veins may become negative. Here's the graph of results for each the multi-stage fitness test and the Wingate. As you can see, there's a higher systolic pressure during exercise. One is pre-test, so we start quite high anyway. However, it does show a steady increase in the systolic, and then the diastolic also does increase as it has to match with the systolic, but because there is less time, there's more contraction than diastolic relaxation. Similarly, during exercise, this will be affected during the increase in exercise as there is a higher demand for more oxygen to be delivered to the muscles as they start to fatigue and demand more ATP energy, and so the systolic value will increase in order to increase the contraction, which will cause a pulse and therefore allow blood to pump.